Hello, everybody. I'm starting this series of statistical analysis as well as of the tests as well as how to do it so that you may be able to do it on your own. The next thing is that I want to do this on open source platforms because frankly, I've gotten tired of everybody using SPSS when there are so many other good alternatives available out there. So today I'll be introducing free software, free statistical software, which is frankly has a very pretty graphic user interface. And also, although it is fairly limited, whatever analysis can be done on that are a little on the smaller side, but frankly speaking, for our purposes, that is more than enough. So I'll be focusing just on that. So the first thing is the software's name is Jamovi, that is Jamovi, and it is based on the R platform. And I'll just show you how to download it and how to install it. So first, I'll be showing my entire screen, sharing my screen. Now, just go over to whatever browser you use and go to jamovi.org. Okay, so this jamovi.org, you will be going to the Jamovi desktop. Do not go to the Jamovi cloud, the Jamovi desktop. Within the Jamovi desktop, there'll be two options, that is solid and current. Go for the solid version. Okay. And once you have downloaded it, I've already downloaded and installed it. So you can also download it. And after that, just double click on the that installer, and you'll be getting it will start installing automatically. It's a fairly painless process. So having said that, I'll just show you briefly how it looks like. Once it is installed, you go to your search and just search for Jamovi. In that, the Jamovi will come, open it. There will be a small loading screen, and after that, it will open up. Yeah. So once it has opened up, I'll describe the GUI in brief, but after that, this is not the core focus of today's video. Today, I'll be showing mostly how to set up your Excel file before you do the analysis. So this is the graphic user interface in which you have got multiple tabs here. Mostly, you will not be using variables or the data tab. I'll be showing you how to modify variables in Excel itself because frankly speaking, Jamovi is not very well suited for that. And in Excel, you have got much more better features to do it. In the data tab, basically, you will be able to see the data. But again, beyond that, I won't be asking you to use any of these other features. But this analysis tab is where your entirety of the analysis will happen. So once you start doing the analysis, you'll see that as soon as you do some analysis, it will show up here. The results will automatically show up here in the right side pane, from which you can right click, copy, and paste into Excel or Word document, whatever you want. Okay. Then after that, there is the edit. This is very similar to your Excel. So, but I would not recommend using it again because Excel is far more suited for these type of purposes. Okay. These three dashes in this, basically you can open or save the thing as a project, as a Jamovi project, and that is it. Open basically means you import the data. Special import is for specific types of files, different types of data files that are available in the market, and like CSV files, etc. And save as is for the entire project. Export is for exporting the data as well as the results in separate files in whatever format you want. Okay. So for now, I'm just closing this and I'll be going on to describing the Excel. So I've been doing analysis for over 10 years now. Actually, more than that, probably around 15 years I've been doing analysis. And I have dealt with a lot of different data sets, however horrible they are provided to me. Now, lately things have improved quite a bit, but like there have been times when that actual analysis would have taken like 2 hours, and the data cleaning itself took some 8 hours. So I would suggest that you make your statistician's life as painless as possible. And because I'll be teaching you how to do the analysis, you are the statistician now. So basically, make your life as painless as possible. Now, let's go on to a pre-configured data that I have made. This is like a random data that I've created for a group-based type of analysis in which you have got time points as well as you have got a grouping variable. So here the grouping variable is group A and group B. And you have got a few demographic variables, a few test variables, and you have got time point 1 and 2 for the test variables. Now, on the outside, it looks like a fairly normal data set for our field. But unfortunately, this type of data is completely inconducive for, not conducive for entering into a data analysis software and doing data analysis. Now, there are a few cardinal rules that you have to follow, and I'll be going through them one by one while I clean up this data set that I have actually made in a way that shows how dirty files can be. Now understand that this is a relatively small data set because you have got a small number of variables as well as less number of rows, that is less number of subjects. But the data files that you work with can have anything from 5 patients to like 800 patients or more than that. And the number of variables can extend into like at least 50 type of variables you can have, and many of them will be in multiple time points. So basically, when you enter the data, there are few rules that you need to follow. And hear me well, it is extremely important. First thing is that this type of a format in which you have got the actual data starting from the third row or the fourth row, however you have configured it, and the column names taking up the first 2, 3 rows of the data set is not proper. Your only the first row Only the first row should have the column names. The data should start from the second row itself. Okay. So here, what I'll be doing is I'll be breaking up this data, and I'll be deleting the unimportant things. And after that, I'll show you how it is supposed to be done. So basically, like you have got a demographics tab up here, which encompasses the age, sex, and ASA. You do not need this tab. Like just from the variable names, you can make out that these are under the demographics because you are the domain expert and you know that these come under the demographics, right? Next, coming to the variables which are like in multiple time points here, there are a few specific things that you need to take care of. First thing is that another way of changing this data would be to write it as HBT1 and suppose HBT2. So here with the column names itself, we are specifying that the HB is measured at T1 and T2. Now, unfortunately, this type of naming can also cause problems because for column names, they have to be solid names. They cannot have gaps in between. You cannot have space inside a column name. Okay, most statistical softwares are configured in that way. So I would suggest that you use, instead of a space, you use an underscore for denoting that. Now, the thing is that in your mind, you can probably use n number of such separators. This is called a separator. You can use n number of separators for denoting the column names. And the very common ones that I've seen are used are hyphen or a slash. So I would, or a forward slash or a backward slash, however you do it. I would suggest you do not use those because those are mathematical operators. And because of that, it can cause problems in the programming language that has been used for creating your software. So do not use any mathematical symbols. Do not use asterisk. Asterisk is basically a symbol which denotes all in programming languages. So I would suggest not using that also. And like, why do you want that many choices? Just use an underscore. It's the simplest, right? So basically use underscore to denote denote the spaces. And for subsequent, if you want more categorizations, like suppose HBT1 for some specific use case, like maybe you're doing it for two separate modalities of measuring HB. Suppose one is a lab HB and one is a HB from that HemoQ device. So then you can do underscore suppose lab, okay, and T2 underscore HemoQ, and so on and so forth. Like basically keep using underscores for prolonging the column name if you want more. Do not use multiple rows for denoting different time points or different ways a variable has been measured. Okay, so there's the first lesson. The second lesson is that do not use a number at the start of a column header. If you use a number, usually what happens is that the statistical software will pad it with another character. So the if it was 1 THB, like first time point HB, it would get converted to X1 THB, something like that will happen. So do not start column names with a number. Always use characters and do not use any separator apart from an underscore. And the first row of the Excel sheet should always contain the column names, and the data should start from the second row onwards. Okay. So now I'll be converting the rest of the data into its T1, T2 formats. Okay. Two, and I'll be deleting this first row. Now that you have gotten everything in the format that is useful for us, now let's go over the next few problems that I often face. Now, the first thing is that there are two types of, like from the programming perspective, there are two types of variables that you'll be encountering. One is numeric variables, and other is your character variables. Okay, in the numeric also you can have integers which do not have any decimal places. There are double slash interval, whatever, there are multiple names for that which have decimal spaces, but they come under the broad heading of numeric. And in the nominal and in the other side, you have got ordinals which can be depicted as characters, or you can have nominal variables which are also depicted as characters. I would suggest that take all of them under the broad heading of character variables. Okay, if you have got ordinal variables in your data set, prefer to put them as numbers, right? Instead of making it mild, moderate, severe, just put it as 1, 2, 3. In your mind, you know that it is 1, 2, 3, right? But if you actually want to use it as a nominal, then prefer the character variables. Okay, this is a character format, like right, mild, moderate, severe itself, not 1, 2, 3. Now, this is one thing that I've seen that everybody has, because SPSS is the most common point and click statistical software which is used out there. Most people have gotten used to writing out the nominal variables, that is the variables which should be represented as character, with their codes, meaning that you have got for mild, moderate, severe, you have got 1, 2, and 3, or 0, 1, 2, or something or the other like that. Now that is useful for SPSS, because SPSS was coded out in a quite a bad fashion. Like this sort of thing should not have been there for user friendliness. But like it's a trivial thing from a programming perspective to at the beginning itself, when you are configuring your programming language or your software, that you said that nominal variables are going to be as characters. Right. So, but unfortunately, they went the other way around, and now all users are used to putting numbers in place of characters. Now, the problem that it creates is that once you enter it into the statistical programming language, the codes, like basically, then this 1, 2, 3 get read as numbers, and then you have to later specify that these are actually numeric variables and not these are nominal variables and not numeric variables. Fortunately, Jamovi doesn't have that problem. So I would suggest you keep the numeric as numeric and the character as character variables. Do not recode anything. If you want to write it as mild, moderate, severe, write mild, moderate, severe. If you want to write it as numbers, if it is a number variable, put it as numbers. All right, just stick to that. Next, if you have nominal variables, the next common problem that I've seen is that you go ahead with typing them out, but they are very inconsistent. So whenever you have got character variables, you will have levels of character variables. Like suppose for sex, you have got levels of male and female, right? In your mind, you know that they are male and female. But when you enter them as capital M, small m, male, and capital F, small f, and female, suppose, like it can be a typographical error. Now, because of this, what happens is that now the software, once you have entered it into the software, it is reading it as a variable which has got 6 levels. That is capital F, small f, capital M, small m, male, and female. You understand? So please avoid this type of thing. If you are setting out to make a nominal variable, make sure that the levels are consistent. The spelling mistakes and everything are not there. If it is a capital F, it stays a capital F. If it is a small m, it stays a small m. Okay. So please make sure of that. So if you have already entered or you're cleaning somebody else's data, the usual thing that I do is I'll highlight the data. Okay. I'll go to the filter tab here. You can see the filter tab. So do the filtering. And after that, I'll be doing it an A to Z filtering. So when you press the filter command in this, then these down arrows will come at the column headers. So there, whichever variable you're looking at, suppose sex I'm looking at, I'll order it by A to Z or Z to A, however. Okay. So with that, now you can see that now all the F's are together. So what I'll do is I'll write a capital F at the top and I will drag it down until the females are there. And then I'll write a capital M here and I'll drag it down to the bottom. So this way now it is consistent. Okay, so now when you put into the programming language or whatever software, it will read it as a variable which has got two levels. Okay. Now, similarly, in this column also group variable, you can see that there is a small a somewhere and there is a small b somewhere and rest of them are capital A, B. Now, unfortunately, the program is reading it as a variable with four levels. Now, you do not want that. Now, what I'll be doing is I'll be again sorting it A to Z, and first is capital A. I'll be dragging this, and next capital B, and I'll be dragging this. Now it is consistent, right? Now, in doing this, you saw that when I was filtering, the entire data set was getting converted into a filtered format, basically in ascending or descending based on that one variable. Now, many times we want to revert it back to its original state, like the original order that the data sheet was in, right? So for that, I always suggest that always have a serial number column. Always have a serial number column or at least some sort of identification column for each patient. So I know that we used to work with de-identified data sets, but when you are an actual analyst, complete de-identification is not a good idea. Even if you completely de-identify, at least retain a serial number column. That is extremely useful, extremely important. Okay. So here, since I already have a serial number column, I can just sort it from smallest to largest. Now voila, I've got the original data in the order that it was already there, right? Now this order is extremely important when you do a lot of changes to the data set while the cleaning is going on. Now let's go on to the next step, dealing with numeric variables. Now in the numeric variables, the most common problems that I've seen is that whenever you have got decimals, you accidentally put in double dots instead of a single dot denoting a decimal, or instead of a dot, you put a comma. So these are like accidents, typographical accidents that you do. Luckily in Excel, you have got a way of like basically whenever Excel reads anything as a number, it puts it on the right side of the cell. Whenever it reads anything as a character, it puts it to the left side of the cell, unless you have put this aligned to the middle type of thing. So once you are done, so after this, you just need to correct this, like I am correcting this right now. And done. Now I feel the data is ready to be imported into your Excel file, into your statistical software. So I save it and I will close this. Okay, so for now, I think we are done. Like these are the common mistakes that happen in data cleaning. Later on, I'll be showing you a few tips and tricks on how to speed up your process of data cleaning or even making new variables if you want to using some functions which are inherent to Excel. So for now, I'll be switching off and I'll see you in the next lecture. Thank you.